So in continuation of the previous video, page number 3.90 in Aurora Problems for Practice, I'm doing the fourth sum in which you have E1, E2 and an R. They've given that a battery E1 is of 4 volts, E2 is of 2 volts, each having each one having internal resistance of 2 ohms. So you have an internal resistor which is 2 ohms, and this has got internal resistor which is 2 ohms, and this external resistor is 8 ohms. Find the magnitude and the directions. Okay, so how do you mark the current of each battery? You have to find the current. You can mark this as I1, you can mark this as I2. So what comes out is I1 plus I2, and you can take it in the anti-clockwise direction. Okay, when I take this, you go from here, it's from negative to positive, which is plus 2, and the current is flowing in the same direction, and there's internal resistance. Don't forget that you have to multiply that resistance into that current with a negative sign because it's flowing in the same direction. Current is flowing in the opposite direction, so it is I1 is the current, so opposite direction means minus 2 I1, and the battery is from positive to negative, so it is minus 4 is equal to 0. So minus 2I2 plus 2I1 is equal to 2. So then you can write it as 2I1 minus 2I2 is equal to 2, and I1 minus I2 is equal to 1, and that will be equation 1. Let's go to the next circuit, which is this. I'm going to go anti-clockwise. I always prefer going anti-clockwise, but Aurora would have gone clockwise. Doesn't even matter. Just go anti-clockwise. Because when I do a square also, no, I'll go A, B, C, D. I'm used to going in anti-clockwise direction, so I would want to stick to that. So when you go like this, you have a current which is flowing in the opposite direction. So I1 plus I2 into 8 ohms, and go here a battery which is positive to negative minus 2, and an internal resistance is the current is flowing in the opposite direction, so plus 2I2 close is equal to 0. So it's 8I1 plus 8I2 minus 2 plus 2I2 is equal to 0. This itself is 10I2. 8I1 plus 10I2 is equal to 2. 4I1 plus 5I2 is equal to 1. This is my second equation. In order to cancel them off, I am multiplying this entire equation with 4. So when I do that, I will get a 4I1 minus 4I2 is equal to 4. A 4I1 plus 5I2 is equal to 1. Minus minus, this get cancelled. Minus 9I2 is equal to 3. So I2 is equal to minus 3 by 9 or 1 by 3. Don't worry about the negative answers, just leave it like that. It only shows that our assumption of direction is wrong. So can you imagine the current is flowing like this in I2 and not like that? It's just a conclusion. Don't have to worry, you just have to make it. It is in a larger circuit, it's not necessary that the current emanates only from positive. It can flow in any direction depending on which wing has a higher potential, low potential, you never know, right? So then which has greater resistance, so you have to use the Kirchoffs law loop rule to find out. So let's leave it like minus 1 by 3 amps. Okay, now you can substitute this in one of the equations, and you can get in this equation straight away, where I1 minus of minus 1 by 3 is plus 1 by 3 is equal to 1. I1 is equal to 1 minus 1 by 3, therefore the answer is 2 by 3 amps. Thus you get what is the current flowing through the battery E1 and battery E2. Okay, that's the sum. Let's do another sum, which is the fifth sum. Okay, I have a battery which is connected like this, a resistance which is internal resistance of the battery. That's what it means. E1 an internal resistance of this battery, and E2 an internal resistance of this battery, and E3 an internal resistance, and so on. Okay, all of them are different values, and you have a battery and an Rn, En and an Rn. Okay, so then you have a circuit, and they have given the current in this direction. I'm reading the question for you. Shows N cells connected to form a series circuit. Then the internal resistances are related to their EMFs as R1 is equal to alpha into E1, where alpha is some constant. Okay, the internal resistance is related to their EMFs by this, where alpha is some constant. Okay, the current through the circuit, find the current through the circuit. So I is equal to question mark. Okay, and the potential difference between the terminals of the battery. Okay, so between the terminals means between this end and this end, and this end and this end. You have to find the potential difference between those ends. Let me try the question for you. So let's assume that the current flowing through is I. It's been given in this direction. So let's go anti-clockwise. Let's start the journey. So the internal resistance, current is flowing the same direction, minus IRN. And then there's a battery, which is the N battery, which is plus EN. And then dot 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 dot, the current comes in here. You have a resistance R3 where the current is flowing in the same direction. So minus IR3 plus the battery is from negative to positive plus E3 minus IR2 plus E2 minus IR1 plus E1. So can you see that let's consolidate all the i's together. Okay, so you have an I into minus I into R1 plus R2 plus dot 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 Rn plus E1 plus E2 plus dot 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 En, and that is equal to 0 considering it's a closed loop. Yeah, so but it's already given that R1 is equal to alpha into E1, so substituting that, alpha E1 plus alpha E2 plus dot 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 alpha En plus E1 plus E2 plus dot 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 En is equal to 0. So can you see, if you take alpha out here, you get a E1 plus E2 plus dot 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 En plus E1 plus E2 plus dot 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 En is equal to 0. From these two terms you have E1 plus E2 plus dot 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 En itself. Yeah, and so you were left with minus I alpha plus 1 is equal to 0. This cannot be 0 because they are given EMFs and they are connected in properly only, it's not even getting cancelled off, correct? So this cannot be 0, therefore this has to be 0, minus I alpha plus 1 has to be 0. Therefore minus I alpha is equal to minus 1, therefore I is equal to 1 by alpha. Thus you find this many amps is flowing through the current, flowing through the circuit. And to find the potential difference between the terminals of the ith battery, the potential difference between the terminals of the ith battery. Okay, so potential difference between ith means you know that it's E1 minus IR1. Okay, so E1 minus IR1, EI minus IRI. This is the potential difference. Because I have told you, when you have a battery and a resistor, you want to find the potential difference between this and this, and the current is coming like this current, and you're going anti-clockwise direction from left end to right end. When you're going from left end to right end, it is not a closed circuit. In this case, what I'm doing here is an open circuit from this end to this end. You want to find the potential difference between, this is, call it as A and B. You want to find the potential difference between VAB. You do VB minus VA. We have to come in this direction. So when you come in this direction, obviously the current is also coming in the same direction, and this is RI and this is EI. Since the current is coming in the same direction, minus IRI, battery is from negative to positive plus EI, and it's not equal to 0. This itself is the potential difference. You can't, sorry, I hope you are able to hear. You can't write it as equal to 0 because it is not a closed circuit. It's from this end to this end. You want to find the potential. You just have to find come from there to here, from A, B. If you want to find, come from B to A, travel along and apply loop rule, but it's not closed, it's open, so you can't equate it to 0. That will give you the direct potential difference between this end and that end. You already know Ri is equal to minus I into a relationship which is alpha into EI, alpha into EI plus EI. Alpha into EI plus EI is the value for Ri, and but you know I itself is 1 by alpha because series circuit. So minus 1 by alpha into EI plus EI, so alpha get cancelled, so the net potential between EAB is 0. Beautiful, right? So that's another eye opener. Okay, so then let's go to any other sum that I would like to do today. Two cells of EMF 3 volts and 4 volts and internal resistance 1 ohms and 2 ohms are connected in parallel so as to send the current in the same direction through an external resistor 5 ohms. Let me do this diagram. This is the 6th question. Two cells of EMF 3 volts and 4 volts, and internal resistance is here 1 ohm is the internal resistance of this battery, and 2 ohms is the internal resistance of this battery. Okay, so then you have 1 ohm and 2 ohm connected in parallel. So I've connected in parallel. Yes, I've connected in parallel. So send the same current in the same direction through an external resistor 5 ohms. So there is an external resistor of 5 ohms. The current has to go in the same direction outside it. Okay, we can assume that this battery is what is coming out is I1, and this battery what is coming out is I2, and what comes out is I1 plus I2. Okay, it's up to you how you want to. This is the way I've decided to keep it. So then draw the circuit diagram. Yes, already drawn. Using Kirchoffs law, calculate the current through each branch of the circuit, the potential difference across the 5 ohm resistor, the 5 ohm resistor, the potential difference across the 5 ohm resistor is what you need to find, or what is it? Potential difference. Yeah, we need to find the potential difference across the 5 ohm resistor. No problem. Okay, so you have a 3 volt and a 4 volt with an internal resistance. Okay, here comes so you know the equivalent resistance for this circuit is R1 R2. R equivalent for a parallel is R1 R2 by R1 plus R2. Let me try this. R1 R2, one is 1 ohm, another is 2 ohm. So 1 into 2 by 1 plus 2 is 3. So 2 by 3, and that is the internal resistance equivalent. And so then I have the total resistance, which is capital R by small r equivalent, which is 5 plus 2 by 3. Okay, which is say LCM, if I take LCM, 17 by 3 ohms is the equivalent total equivalent R, capital R equivalent of the entire circuit. And let's find the ERMS. Okay, sorry, what do you call it? E equivalent, which according to parallel connection is E1 R2 plus E2 R1 by R1 plus R2. That's the formula, right? So E1 R2, 3 into 2 ohms, plus E2 is 4 volt, and the other resistance is 1 ohm, by R1 plus R2 is 3 ohms put together. So 6 plus 4 by 3 is 10 by 3, and that's the EMF equivalent. So you know that E equivalent is so much, you know the R equivalent is also so much. Okay, so what is that you have to find? You have to find the current in each branch. You can find the current through the current in each branch is what they want to find. We can use loop rule. I'm going to show you. I don't know what for I did all this, but you understood. If the question was about to find an E equivalent, EMF equivalent, and an capital R equivalent of the circuit, you can do it like this. And so then, if you want to calculate the current, I'm just wondering, can I do E equivalent by R equivalent, which is 10 by 3 by 17 by 3, which is 10 by 17 amps is the current which is flowing through. And if that is the current, the question is current through each branch. Okay, I know that the current that's flowing through the main circuit, the outer circuit, the total of it is 10 by 17 amps. I can say this, okay. But having said that, I want to find out what is I1 and I2. Okay, if you want to find I1 and I2, so what do you do? Once again, let me think. For some reason I found the R equivalent, I found the E equivalent. I thought the I is equal to E by R gives me my current through the outer circuit. Yeah, fine. But how do I find I1 and I2? So let's apply a loop rule here. And can we go anti-clockwise and start from here? And you know the current is going in, say, same direction. So this is the current. So it's same direction, minus 10 by 17 into 5 for the resistance. Let's continue and go here, come to the outer loop here. Okay, the battery is coming here, that's the lower one, so it's plus 4 volts, and go like this, plus 4 volts. And what about the internal resistance? There's a 2 ohm resistor, and the current I2 in the lower wing is the current I2, which is flowing the same direction, minus 2 I2 is equal to 0. Yeah, so minus 50 by 17 plus 4 minus 2 I2 is equal to 0. Let's see if it's correct. I don't know. What is 17 4? So suppose 28, 4 1 4 5 6. So it's plus 18 by 17 minus 2 I2 is equal to 0. 2 I2 is equal to 18 by 17. So can I say 9 by 17 amps is the current that's flowing through the bottom I2. I got I2. So it's just as simple. As usual, you do a E equivalent, you find R equivalent, you find the current through the outer loop, and then just apply loop rule for the bottoming. Now same thing, you can take the outer one. You know, I'll write it in green color. For this one, I'm going to apply a loop rule. Okay. So then going like that, starting from here, let's try to travel. Yeah, as coming current is flowing the same direction, minus 10 by 17 into 5. Okay, you can do any way you want. I'm just doing it like this, and going up I have a battery which is plus 3. Okay, and I have an internal resistance on the top one which is 1 ohm, and the current is flowing the same direction, so minus I1 and come down like this and close the loop is equal to 0. So outer loop, just coming outer, just outer, and you get to be close the loop is equal to 0. And so minus 50 by 17 plus 3 minus I1 is equal to 0. And 17 3s are so it's 51. So 1 by 17 minus I1 is equal to 0. So I1 is equal to 1 by 17 amps. Thus you get it. It's such a beautiful sum. Are you clear? I hope you're all very clear. Fantastic sum. Okay. When I started, I had no clue how I'm going to do it, but I just proceeded like this and I got it. Okay. So next thing, let's go to next sum for the day. I want to continue doing it in the same order. They're also asking for potential difference across 5 ohm resistor in the same sum. You know, this is the current. You just multiply the current and the ohms, and 10 by 17. So it's 50 by 17, right? 10 by 7, 50 by 17. Yeah. So the voltage, you know, V is equal to IR. The current flowing through that is 10 by 17 amps. And the resistor is 5 amps, so 50 by 17 volts. So the answer is, this says 2.35. Hope I'm right. Okay, that's what it is. So next question is the 7th question in this. It's also come for a CBSE paper. You have a battery and you have a 2 ohm resistor. You have the battery to be E1 is equal to 12 volts. Then you have another resistor which is 4 ohms. Then you have another battery which is 6 volts. Okay, and so then the current that's flowing through here, this is called I1. There's another current which is flowing through here, and as usual you can mark this as I1 plus I2. He himself has given. Otherwise you can also take middle one as I and split as I1 and I minus I1 at the top, at the bottom. It's your wish how you do it. So now the electric network shows you have consumed calculate the power consumed with the resistance of 4 ohms. The power in this is what the question, power. Okay, for which you should know current. If you know current, P is equal to I square R. Very simple. It's a formula. If you have to know the current through 4 ohm resistor, you have going to apply loop rule and you're going to do the sum. As usual, let's take this loop. I'm not even naming it. You know what I'm going to do. I'm going to go like this. So it is minus 6. And it doesn't, they are not given that it's got any internal resistance, so happily you can go here. And when you go into this, the current is flowing in the opposite direction, so it's minus I1 plus I2, opposite direction, plus I1 plus I2 into 4, I'm sorry, opposite direction. So just close it. Okay, okay, they have not given any internal resistance of any battery, so I just have to write the statement and equate it to 0. So I get minus 6 plus 4I1 plus 4I2 is equal to 0. 4I1 plus 4I2 is equal to 6, and 2I1 plus 2I2 is equal to 3 is equation number 1. Let's do the same thing for the upper loop. It's very, very simple. So let's take it like this. So the current is flowing in the same direction. So minus I1 plus I2 into 4 ohm, and to the 2 ohm current is flowing the same. This I1 has to be taken in the upper loop, so it's flowing the same direction, minus 2 I1, and the battery is going from negative to positive, so it's plus 12 is equal to 0. Close the loop. That's all. So then minus 4 I1 minus 4 I2 minus 2 I1 plus 12 is equal to 0. So this is minus I1 and I1 is minus 6 I1 plus 4 I2 minus 6I1 minus 4I2. Minus 4I2 is equal to minus 12. 6I1 plus 4I2 is equal to 12. And 3I1 plus 2I2 is equal to 6. And this is my second equation. And you can solve this straight away because you have 2I2 and 2I2. 2I1 plus 2I2 is equal to 3. 3I1 plus 2I2 is equal to 6. Minus this get cancelled. You have minus I1. Minus I1 is equal to minus 3, so I1 is equal to 3 amps. Thus you get I1, which is the current through top one. You want I2 also, so substitute it in one of the equations. Take any equation. 2I1 the purple color equation, plus 2i2 is equal to 3, 6 plus 2i2 is equal to 3, 2i2 is equal to minus 3, and i2 is equal to minus 3 by 2 or a minus 1.5 amps. So thus you get i2, and you know i1 plus i2 is the current flowing through middle wire. So it's negative, this is negative and that's positive, so you have to take it as 3 minus 1.5. Current flowing like this and coming like this will get cancelled off, and you get that's the current that's coming through, which is only 1.5. And you want I square r is what is power, so it's 1.5 the whole square into that resistance. What is its 4 ohm resistance? So it's 2.25 into 4, 5 4s are 20, 5 4 4 4 2s are 8, 4 2s are 8 9. I'm getting 9 watts to be the power, and it's the right answer. See, so this is the way you have to continue with the sum. So let's go to next question, which is the 8th question. The 8th question, okay, there is a 2 ohm resistor, a 2 ohm resistor, a 2 ohm resistor, a 2 ohm resistor, and from here there's a 2 ohm resistor and comes out and is connected to a battery. Okay, so this is what it is. They have named it as this point as A, this point as D, this is C, this is B, and they've given the battery is E, and they've given the current to be 2 amps. A network of resistors connected to a battery of negligible internal resistance. So battery doesn't have any internal resistance. Calculate the equivalent resistance between the point A and D. So between the point A and D, equivalent resistance we have to calculate, which means AD has to be treated separate and all the above has to be treated parallel. Anything above AD is in parallel with AD. So looking at this, can you see that this is a 2 ohm resistor, this is a 2 ohm resistor, both of them are in series. These two are in series, which is 4 ohms. Yeah, that 4 ohms and the middle 2 ohms is in parallel. Yeah, that 4 ohms, the middle 2 ohms is in parallel, which is 4 by 3 ohms. That is in series with this 2 ohms. The entire thing is in series with this 2 ohms. So then 4 by 3 plus 2 is 10 by 3 ohms is the total resistance above, for the above one. Yeah. Now that is in, what about this? This also 2 ohms, and that is in AD is to be treated parallel. So 2 into 10 by 3 by 2 plus 10 by 3. R1 R2 by R1 plus R2. 20 by 3, and this is 16 by 3. 20 by 16, which is 5 by 4, and 5 by 4 itself is that's all. 4 ones are 4. I think this is the value of equivalent resistance that I'm getting. I'm just doing the sum, treating the sum very normally, considering these two are series. It's 4, that and this 2 is in parallel, so 4 into 2 by 4 plus 2 is 8 by 6, which is 4 by 3. That and this 2 ohms are now in series, so 4 by 3 plus 2 is 3 is LCM, 6 plus 4, 10 by 3 ohms, and that 10 by 3 and this 2 ohms are in parallel, so 2 into 10 by 3 plus 2 plus 10 by 3. It's parallel. Okay, 20 by 3 by 16 by 3, so it's 20 by 16, and 4 4 16, 5 4 25 by 4 is what I'm getting. Calculate the equivalent resistance between A and D and the value of I3. Okay, but I'm getting 1.25. It's 4 ones are 4. Then 4, I'm not getting 1.25. Am I getting 1.25? 5, 4 ones are 4. I'm getting 1. Put a decimal. 0, 4 twos are 8. 2, yeah. 2 5 4 so 1.25, yeah, correct only. So I'm getting a 1.25 ohms. That's sorted. That's the equivalent resistance. And find the value of I3. Okay, find what is I3. Okay, they have marked some currents here in the circuit. I didn't use loop rule to find the equivalent resistance. I just did normal series and parallel in this sum. There's no necessity to use loop rule. They're asking me to find what is I3, which is the current flowing through this wire. So current flowing through this wire, they're asking me to find the current flowing through this wire. Oh, then I have to necessarily use the loop rule. Then I have to necessarily mark the current. Okay, so then the current of 2 amps that is going in here. Okay, there's a 2 amps. I can't write it as 1 amp and 1 amp because altogether this is in a different wing. It's not symmetrical. Okay, so okay, coming back to this, what did I say? Yeah, current through the 2 ohms, you have to use only loop rule in that case. Okay, so let's mark the currents. Okay, he himself has marked the current also. Okay, but in case he had not, then how do you do it? 2 amps coming here, the total current is 2 amps. Okay, and the total voltage of the battery has not been given. But you know the equivalent resistance, right? You know this is the equivalent resistance. You know the current is 2 amps. So can I find, so then can I find EMF is equal to IR, which is 1.25 into, the current is 2 amps, sorry, 2 amps into resistance is 1.25, which makes it 2.50. Can I say this is a 2.5 volt battery? I don't know. They've not asked me for it, but I'm marking it. Okay. So now, so they have also given, okay, you know that this current will be, if it is I1, this will be 2 minus I1. You know the total current is, so there will be 2 minus I1. And, but you do not know how much current will flow through here. It's going to get split up. So better to write it as, instead of 2 minus I1, write it as I1 and this is I2. So that this will be I3. And this will be I2 minus I3. That's the only thing I can write properly, I2 minus I3. Okay, in this case, that's how I can write, correct? And so then I'm going to find, in order to find the I3, can I, which route can I take? I'm just thinking. Okay, I'm going to do this. Just watch what I'm doing. I know that the B and D are at the same potential, BD, between B and D. And that, and when you come like this and like this, is going to be having the same potential. So I'm thinking, can I equate both the potential? Can I equate both the potential? Would it work? So if we want to find the potential between VBD, it's VD minus VB. So I'm going to go from D to B. If I go from D to B, the current is flowing in the opposite direction, which is a plus 2I3. That's all. And let's go from the outer, through the outer wing, let me go. If I'm going to go from D to C, DCB, I'm trying to find the potential between VBD, same VBD in the other direction, which is coming from D to C and C to B. Okay. So if you see in that, the current is going in opposite direction, no, the same direction. When I go anti-clockwise, it's obviously in the opposite direction, plus I2 minus I3 into 2 ohms. Again plus I2 minus I3 into 2 ohms, so you can say plus 4, because the current is flowing in the same direction, which is, no, in the opposite direction, and there are just 2 ohm resistor. I can equate this with this. 2I3 is equal to 4I2 minus 4I3. I'm just exploring, okay? It works, it works. 6I3 is equal to 4I2, and I get a relation between I2 and I3. 3I3 is equal to 2I2. So thus I get a relation between I3 and I2. And all I need to find is I3. So I want, I equated and I got some relationship. Now let me do, if I take this loop, I'll get an I1, I'll get an I2 and an I3 and an I1 also. So I'm deciding, look at what I'm doing. I'm going to go like this, 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 like this. I'm trying to do something different, okay? Just exploring. So when I'm going in this direction, yeah, the battery is from positive to negative, minus 2.5 volts. Come to D, and I'm going in this direction, and when I go diagonally upwards, the current is flowing in the opposite direction, plus 2I3. I get it, I'm trying, okay? And when I go down from B to A, the current is flowing in the opposite direction, so plus 2I2. come down and close the loop. That's all, the battery is closed, so is equal to 0. And so then I get another equation here, 2i3 plus 2i2 is equal to 2.5. I already know relation between I2 and I3, and an I3 can be written as, I want an I3, so I don't want to write I3, I want to write I2, and an I2 can be written as 3 by 2 I3. So a 2i3 plus 2 into 3 by 2 I3, so 2 and 2 get cancelled, is equal to 2.5. So a 5i3 is equal to 2.5, and I3 therefore is 2.5 by 5. Which is 1 by 2, so 0.5 amps is the answer. Beautiful. You can think of any way you want. Can you see I've drawn a closed loop in the red color, which is quite different, right, going across a diagonal. So it's up to you how you want to do it, okay? But such a beautiful sum. I hope you're able to play it again and again and get things so much clearer. So it's such an important sum. Okay, and okay, for now, today this is enough, I think. You can practice these sums tomorrow. Like this, every day I'll send you sums so that you get real good confidence. I don't have to teach you then these sums in the class.